All right, very good morning, very good evening, everyone. We are already past 5 minutes. Good to start. Right, so quickly, uh, we will recap what we covered yesterday and then we'll continue from where we left in continuation to the yesterday session. Right, we started with the introduction about your instructor, that is about me, and then my overall experience and my major accomplishment and my expert domains, expert domain knowledge. So who I am, and then my quick little technical background, what I covered yesterday, followed by a course curriculum. So again, if you get a chance, please go over this Malik034blocks.com rack training at HTML, which will have all the course curriculum details. Again, we covered yesterday in detail about all the course curriculum, course content, what we are going to cover in this RAC course. So I'm not going to repeat again. You just go over this link here. I already pinged in the Zoom chat here. You can take a look at that and then try to go over each and these topics. And if any questions around that, you can feel free to ping me. Right, that's about course curriculum and then course durations, timing, fee structure. We discussed about this yesterday, and we'll be taking a 2 days in a week, Thursday, Friday in IST, Wednesday, Thursday in EST, 3 hours each of those days, 8:30 a.m. to 11:30 a.m. IST, or 10 p.m. EST to 11 a.m. EST. Maybe there might be some, I think last 2 days or last 3 days back, there's a DST change happened. It may be 11 p.m. I believe. 11 p.m. to 2 a.m. is the EST timings. Right. Having said that, so 7 weeks we should be able to complete this course, and it's a paid training, 15K Indian rupees or 185 US dollar. Will be conducted over a Zoom session, all the live classes, and we'll be covering 19C version. And starting with the 19th March, we'll be continuing with this regular course. And then post after yesterday's discussion, we got couple of more registration. Previous to that, we have few, and then maybe I have not yet granted access who are registered yesterday. Please stand by. After today's session, I'm gonna register all you guys and then add you to WhatsApp group. All right, that's about the course curriculum, course duration, course timing, and fee structure, what we covered, and followed by Google Drive link. So we'll be having a link one, all the course materials and PPTs, link two, all the softwares and other information. Link three, previous batch recordings. Link four, current batch recordings. And if I get those links here, so link one is a course material, PPTs, workbook, lab exercise, and all the ready VMs. Everything will be there in this link one. Link two, all the softwares, patches, tools, entry questions, and automation scripts and all will be placed in this link two. And link three is about the previous batch recordings. You can see these are the previous batch recordings plus all the notepad, whatever we demonstrated in my lab will be attached here. And then link 4 will be current batch recordings. This is yesterday's demonstrations and associated notepad what we created. But those are the Google Drive link access. You'll be getting it once you register for this course. And for that, the registered student will be part of the WhatsApp group. All the questions, queries, any doubts, or any help or any assistance, everything will be discussed in one single group, WhatsApp group. And then again, this group will be there forever, even after completion of the course. We'll be regularly in touch. We'll be conducting some extra sessions, classes, or any assistance or any help you needed, or any interview preparation you need, assistance or interview preparation or guidance. So we'll be communicating through WhatsApp group, and then We'll be regularly connecting over a weekend and having some technical discussions. But that's the beauty about WhatsApp group and the Google Drive link. Again, we talked about this Google Drive link. There's no restrictions. You can have a lifetime access. Or if there's any changes in the link, then I'll be letting all you guys know. Great. After that, we talked about the payment mode. So as I just mentioned yesterday after the demo sessions, we got couple of more registration, and feel free to ping me on my cell number or my WhatsApp number, or call me on my cell or WhatsApp for further registration process and payment processing. I'll guide you to the step-by-step procedure. All right. Post that, very important thing, we talked about the prerequisites, what are needed for this course, the basics of Linux, Windows, and prior database knowledge, and the hardware requirement are must. And once you meet this one, you can continue for or register for this course. Right. Post that, I just given a recommendation. What is the best laptop you should offer or you should buy? You should have minimum 32 GB RAM and 64 GB RAM. Any one of that you can go for that. With a minimum 250 or 500 GB or 1 TB SSD hard disk with a minimum 2 to 8 cores and latest processor. Try to buy the laptop and then you can easily set up your rack, standalone data guard. Right, and then we talked about what will be covered in this course, what is the platform, and then we talked about Oracle certificates, how important to have this Oracle certificate, and then we talked about the new technologies, AI, ChatGPT, Cloud, and cloud, and many more things. And then learning DevOps, Oracle Cloud, and I have career gap. What are the best practices I should follow? We just covered that. And then post that, we started with some technical discussion. And then in technical discussion, we talked about type of databases, standalone versus RAC, and then why Oracle recommend to run on ASM, and then what is the advantages of RAC, and then difference between the RAC and standalone. So that's what we covered in yesterday's session. So I'll take a pause here for a minute if you have any further questions, what we covered yesterday or what I just briefed. If no questions, then I'll continue further with the some fundamental discussion. All right. I'll take it as a no at this point, no questions. Then I'll continue. Uh, Very first thing today, what I want to cover, networking in RAC. Very basic questions when you attend for interview. How many IPs are needed for setting up of two-node rack? Or you may get a question, what are the type of IPs are needed in setting up of two-node rack? So if you consider I'm going to set up a two-node rack, let's say node 1 and node 2. Again, we call it as a node 1 and node 2. That's nothing but your server 1 or server 2, your Linux machine 1 and 2. So we best, very first IP what we need is we need a public IP. We call it as a public IP or the physical IP. Public IP or a physical IP is nothing but the IP assigned to that particular host via any NIC card or any interface. Let's say I have node 1 localdomain.com. I have assigned IP 192.168.1.101. I have this node 2.localdomain.com. Then I have IP 192.168.1.102. This is my first setup IP, two IPs. Again, if they may be asking questions, what is public IP and what is physical IP? The IP assigned to an interface and associated to a Linux machine. So that is one set of IP what we need. And post that, we need a private IP. Again, private IP is also physical IP. So the moment you say physical IP, the IP is assigned to an interface or the NIC card on that particular system. And one is public IP and one is private IP. Public IP is IP which is accessible outside of your domain publicly. And private IP is IP which is in different domain, which is accessible within your, which is private IP is IP which is in a different subnet, but which is accessible only within your domain. So if you observe both public IP and private IP, both of them are physical IP. Physical IP meaning they are assigned to an interface or the NIC card. And one is public, which is accessible outside of your domain. One is private, accessible only within your domain. So one is starting with this one dot subnet, other one is starting with two dot subnet. This one dot subnet is a public IP which can be accessed outside of your domain. Other one is two dot series, which is a different subnet, which is a private subnet, which is accessible only within your domain. This is first set and this is second set of IP what I need it in order to set up two node rack. And then third set of IP what we need VIPs. So node 1 prive.localdomain.com, node 2 prive.localdomain.com, that's a private host name and the private IP address. And the VIP, the name suggests virtual IP. It's not a public IP or it's not a private IP, which is a VIP. A public IP and private IP both are physical IP associated to a NIC, and these are your VIPs. VIP meaning which does not have any NIC card or interface. So node 1 vip.localdomain.com, node 2 vip.localdomain.com, 192.168 1.103, 192.168 1.104. Here 101, 102, 103, 104. All of them are this one dot subnet, which is public subnet, which is accessible outside of your domain. But the difference between this public and VIP, public IP is a physical IP, VIP is not a physical IP. Public IP is assigned to a NIC card or interface. VIP is not assigned to any NIC card. And then followed by after VIP, we need a minimum or a best practices of three IPs. That is three VIPs or three scan IPs. Scan VIP or the scan IP. Some people will call it as a scan IP. Some people will call it as a scan VIP. So scan.localdomain.com. So which will be best practice is to have three IPs minimum. You can go with a 4, 5, even 1, 2, 6, whatever it is, doesn't matter. But best practice is go with a 3 as a default. So again, if you see IP 192.168 1 dot, 105, 106, 107, three IPs assigned to a single name or the single host, which is scan. So these are your bare minimal required IPs in order to do two node rack setup. So by looking at this one, what I just given explanation, there are so many questions you may get it in the interview, you may face in the interview. What are those? What is public IP? What is physical IP? What is private IP? What is VIP? What is CAN IP? And then you may get a question, how many IPs needed in order to set up two node rack? The very first question what I talked. By looking at this, you can able to answer two public IP, two private IP, two VIP, and three scan IPs. Public IP2, private IP2, two VIPs, and three scan IPs. Altogether is your total IP required for setting up of your two node rack. So if you want to do three node rack, how many IPs are needed? So it's the same thing. Node 1, node 2, and node 3, which is public IP. Private IP, node 1 prive, node 2 prive, node 3 prive, three private IPs. Node 1 VIP, Node 2 VIP, Node 3 VIP, three VIPs. Your scan remains same. It will be three. That's the best practice. You can go with the scan 1, 2, with the scan with IP 1 or 2 or 3 or 4 or 5 or 6 or whatever it is. But best practice or standard practice is three IPs are needed for scan as the best recommendations. Remaining all public IP3, private IP3, VIP3, and your scan is 3. And same way, if you want to set up 4 node rack, how many IPs are needed in order to set up 4 node rack? You have 4 public IP, 4 private IP, 4 VIP, and scan remain 3. So that's your calculation, or that's your answer. And with that, you might be wondering further more questions, or you may be thinking few more questions like, why these many IPs in rack? Can I just use one set of IP, public IP, and ignore all of them? Why public IP? Why physical IP? Why VIP? Why scan IP? That is the fundamental questions. You might be getting it. Right? So you have to go back to little bit history to understand that. Prior to 10G, there is only public IP. There is no VIP. There is no private IP. There is no scan IP. Right? Prior to 10G, there were no VIP. There is no scan IP, or there is no private IP. Nothing like that. What are the challenges prior to 10G? If you don't have VIP, if you don't have scan, if you don't have private IP, there are a lot of challenges we had it in prior to 10G. Prior to 10G, we used to call it as a parallel server. The failover was not possible. The load balancing was not possible. Node addition, node deletion was challenging. Right? Meaning, let's say you have this two node rack prior to 10G. It is only, or else we'll go with this one. Okay, we'll go with this one. Prior to 10G, let's say there's no scan and there's no VIP and there's no private IP. When the client used to connect, client directly used to connect to this physical IP and then connect it to node 1. And then again, client 2 used to connect to physical IP, connect to this node 1. If this node is not available, then client used to go to second node, physical IP. Client used to connect to that physical IP and connect to the second node. So what used to happen here? Always all the client connection has to go to only node 1, no load balancing. If the node 1 is not there, then connection used to go to second node. Always your node 1 is heavily loaded. Node 2 will be always idle. That is the challenge what we had it prior to 10G. That's where there is no load balancing. Only connection is always used to go to node 1 only. If node 1 is not there, it used to go to node 2. And in case if the client connected to node 1, let's say is connected to node 1, and if the node 1 goes down, his connection is to break. There is no failure concept. There is no failure at all in prior to 10G. So that is the other challenge, failure. And then client used to connect using this TNS entry. And then right now it is a 2 node rack. And if it is 3 node rack, if we add one more node, and client side all the TNS entry, we need to manually change it. Node addition or node deletion. Let's say it's a 4 node rack. Later you remove one of the node rack, one of the node and make it 3 node. The node addition and node deletion are going to be little more challenging. We need to reconfigure the application. We need to reconfigure the client connection. These all were the challenges prior to 10G because of we had only public IP. So what we did again in our regular class, we'll go more details about the TNS entries, how it was looked like earlier, and then how it is looking like after scan. Those all we can go and then expose in a real-time live demonstration. But for now, let's understand what I just mentioned here. So in 10G, VIP got introduced. Oracle came with a new concept called VIP. So then earlier we had this public IP, and now VIP got added. Two set of IPs we got it. Meaning in 10G, no scan, we have this VIP and we have this physical IP. No private IP, we have this physical IP and we have this node IP. So now the client earlier used to connect via this physical IP. So instead of physical IP, client is now will connect via this VIP. But again, all the client connection will go to only node 1. All these four will go to node 1 via VIP. Always this node 1 will be heavily loaded. If the node 1 is not there, then only the connections will go to second node. But what happens here now? If the client is connected via VIP, if this node 1 is not available, goes down, this client, this VIP will fail over here. When the VIP will fail over, the client will automatically connect to your second node. We are able to get the failover with help of this VIP. But the load balancing is again challenge. Always all the connections will go to node 1 only. If the node 1 is not there, it will go to second node. And if any clients are connected to node 1 via VIP, and if the node 1 goes down, automatically all the connections will go to second node because of the failover. So with that, what we are able to achieve in 10G, failover was one of the challenge prior to 10G, and we are able to achieve this with help of VIP. When the node is failed or when the node is crashed, automatically that VIP will fail out to your other node, and all the client connections will be automatically connected to your second node. But load balancing is again challenge. Always all the connections will go to node 1 only. Again, when you add a node or delete a node, again that's a challenge. You need to reconfigure your entire application. Right, then what happened in 11G? A scan got introduced. Scan IP or scan VIP introduced. Oracle has introduced the scan IP. Now we end up with three set of IPs. Public IP, physical IP, VIP, and the scan IP. Right? And that private IP will be there for internal communications, even 10G or prior to 10G or 11G or 12C, whatever. That private IP is always there. I just mentioned it was not there, but private IP is not a matter. It is all internal communication. That private IP was there forever. So now this 11G scan IP got introduced. What happens? Now the client connections will go to scan. Via scan, connections will go to that node VIP and it will connect over here. Your scan is smart enough or intelligent enough. Scan knows, okay, client 1 connections is connected to node 1. And when the client 2 connections comes, scan is already aware of, already node 1 has one connection. Let's route this connection to second node. And then third connections comes and scan is already aware, connection 1 is on node 1, connection 2 is on node 2. Okay, node 1 is heavily doing a lot of transactions. Let's route this client 3 connection to your second node. Meaning scan is intelligently routing that load equally on all the cluster nodes. So that's where we are able to achieve the load balancing. Right? So what happens with this one? Failover we're able to achieve by VIP, and then load balancing we're able to achieve using scan VIP. Scan is aware of that how many connections are there on each cluster node and what are the transactions are happening. And now deletion and no deletion we're able to achieve by scan because client is always using a scan name. That's a single name. If it's a 2 node rack, 3 node rack, 4 node rack, 5 node rack, doesn't matter for me. My scan is already aware of that. How many nodes are in my rack cluster? Is it a 2 node rack cluster? Route all the client connection to either node 1, node 2, node 3, node 4. If it's a 8 node rack cluster, my scan is aware of that. It's a 8 node rack cluster. Route the connection to your node 1, node 2, node 3, node 4, node 5, node 6, node 7, node 8. So your node addition, node deletion is not an issue anymore. My scan is aware of that, right? So that is where we are able to achieve all the load balancing, failover, node addition, and node deletion. And then why Oracle has end up with all these many IPs? Why public IPs? Why private IPs? Why VIPs? Why scan IPs? Those are like evolved with the various version. If you look at this history, 10G, prior to 10G, post 10G, and 11G, and that's where Oracle is end up with these many IPs: public IP, private IP, VIP, and the scan IP. Right? So we got to know now why these many IPs. That's all like evolution. But the underlying questions, why scan is three IPs? If you see here, if it's a 4 node rack setup, three scan is the best recommendations. If it's a 3 node rack setup, three scan IP is the best setup. If it's a 2 node rack setup, three scan is the best type setup. Again, that's the best practice. It doesn't matter. It's not going to stop you. You can use one scan IP or two scan IP, three, four, five. But three is the best practice. So you can say why three IPs or why multiple IPs for scan. Answer to that is it is for the client side high availability. Meaning, let's say, assuming that I don't have this scan 2, I don't have this scan 3, I have only this scan 1, only one IP, 105. If the client try to connect to your cluster and then you're going to use this IP and the connection will go to node 1. And if the client 2 try to connect to cluster via the scan with this IP 105 and then try to connect. Due to some reason, this 105 IP is busy or something happened in the networking side. And if the client try to connect and then these connections will be broken or timed out because this IP is stuck or busy or not doing a proper job. Maybe some issue on the networking side. So client 4 try to connect. Again, that connections will be broken or busy. So to avoid that, if this one IP is busy, automatically second IP will come into picture. It will take this client connection, third client connections, and with the help of this 106, the connections will go to second or no first node. Client 4 connection comes, again next IP will take that, serve that request, and then go to your second node or third node. So just to avoid that client connection, timing out, these multiple IPs will take, if one IP is busy, another IP will take that incoming connection and then establish the connection to your cluster. That's the purpose of why you should have multiple IPs for the scan. Even you can go with one IP, that's fine. Even you can go with the two IP, that's fine. Three is fine, four is fine. No hard and fast rule. But the best practice or recommendation is should have a three minimum scan IPs so that if one IP is busy, other IP will take over that incoming connections and then serve that client connections. It is for the client side connection high availability. So client connection should not be broken if one IP is busy. All right. So again, further to answer those questions, why or what is physical IP or public IP? The simple definition is IP assigned to interface. If you have interface ETH01 or ENSP012, so if any IP assigned to that, that's your a physical IP. And if that IP is in a public subnet, that's a public IP. What is public IP? IP is accessible outside of your domain, publicly accessible. What is VIP? VIP does not have any interface, like whatever this interface. It will not be having any interface. It will be just pegging or tagging to whatever the available interface. ETH colon 1, ETH colon 2, ETH colon 3. Those are your VIP. It is not associated to any interface or the NIC card. What is scan IP or scan VIP? Again, some people will call it as scan IP. Some people will call it as scan VIP. It's nothing but your VIP. Whatever this VIP, this is same as your scan VIP. IP does not have any interface. That's the meaning of VIP. What is private IP? Private IP is again is your physical IP. IP is assigned to interface, right? Your private IP is nothing but a physical IP, whatever we talked about physical IP, but in a different subnet other than your public domain or public subnet. Right? So these are your same whatever we talked here. So that's your quick one-liner definition in the interview if they ask what are these IPs. So that will be your IP. So again, further questions. Is the scan VIP or the scan physical IP? Answer is scan is a VIP, just like your node VIP. Right, again, further to question why private IP is in different network. If you talk about here, or if you go back here, my physical IP, 1 dot series, my VIP, 1 dot series, my scan is 1 dot series. And if you talk about this private IP, which is a 2 dot series, different subnet. Why private IP is in different network? If you look at here, if the client comes, client will go over here. Via that client may go to your node VIP or the client may go to your physical VIP, physical IP. All of them are in public domain. If you see it's a green color, green color, green color, and green color. That's your public network, publicly accessible. Those are all used for your client connection. So client can connect your scan, or client can connect your node VIP, or client can connect your physical IP. So these all are publicly accessible. But if you look at your private IP, node 1 private IP, node 2 private IP, which is 2 dot series, which is in red color here. And that is your private network, which is within your domain, which can be accessed. So that private IP is used for your node to node communication or node to your disk communication. That's your fundamental need. Why private IP is in different subnet? Because your private IP is for end user communication, end user data flow. We don't want to interfere or we don't want to burden or put a lot of load or data transfer in the public domain. So public domain is for client data, client communications, or client select queries, or client insert queries. All the data is go through the public domain or public network. But internally to communicate between the rubric or internally to communicate between your RAC nodes or database instances or ASM instances or database to your disks, all these communications to happen through this private network. So for that, we should have a different network. We don't want this private communication to interfere with my public network. Why can't your private IP same as your public IP, public network? So what I just answered, your private IP is more used in cluster communication between your node to node communication, node to disk communication. The internal communications, we use this private network. We use for network heartbeat check, node to node communication. We use this private network for disk heartbeat check, node to voting disk communication. We use this private network for cache fusion. Cache fusion meaning the data transfer between your one instance to another instance. Again, this is also one of your interview questions. What is cache fusion? Transferring blocks from one database instance buffer cache to another database instance buffer cache. So you can transfer from this DevDB instance 1 to DevDB instance to buffer cache. Or you can transfer your data from or data block from database instance 2 to instance 1. That's your cache fusion. So for the cache fusion, and then your all internal cluster communication between ASM to ASM, between database to database instance. All this communication happens through this private network, and this private network is heavily used. If you use this private network in the public network, then your public network is always overloaded. Your end user may see that packet drop or packet connection lost. So many issues on the network. Because of that, Oracle has a two different network. Public network is for all the end user data transfer, and the private network is for internal cluster communication. Right, again, further to this private network, we do have something called HAIP, high redundant IP. Whatever this physical IP, which is public IP, VIP, and scan IP, are meant for your client communication and will be a same network. So these all are same network. And whatever this private IP is so your physical IP or the public IP, or let's go with this one, public IP, and then make this as a physical IP. Public IP is a physical IP. Physical IP meaning assign auto associated to interface. Your private IP is also a physical IP. So same definition are meant for internal cluster communication. A simple definition, your public VIP and scan are meant for your client connections and client transactions, and all of them are in same network. Private network are meant for internal cluster communications and will be in a different network. We don't want to interfere this private network with this client network, because private network will do heavy transactions, internal communications, and the end users or the client may face some network packet drop, network issue. So since this private IP is so heavily used, we have something called HAIP. So you just think of it's a bonding. Again, we'll talk about in our regular classes what is HAIP and what is bonding, and we call it as a cluster or like interconnects. We call it as a cluster interconnects or the bonding HIP. That's all your some enhancement in your private IP. So you can bond your private IP 1 and 2 and make it as a active and passive. If one interface goes down, you have other interface to have this proper internal communication. All right, so that is wow, right? Like if I just started with this networking and then how where we ended up with. So is that really matter? Like, am I able to understand or am I able to remember all these things? Again, once we continue with our regular course, we'll go in more details about all this. And then once you start working on RAC, this is all basics and you will be able to remember and then you will be able to answer. And if you think of how many questions we uh, handled here, These all are the proper interview questions what you can expect in the interview. Right, I'll take a pause here for a minute if you have any questions around this. I know this is too early and then it is too internal to this rack, but if you start working, this are all just basics. If you go cluster internal, there will be too much you have to learn in rack cluster. But this is a fundamental basics, and fundamental basic itself is this much of complex. I made it so simple. Hope that's clear. I'll take a pause for a minute if you have any questions around this IPs and networking.
Yeah, hi. Good morning, sir. This is Ashok.
Yeah, sure. Yeah, go ahead.
Yes, sir. Like recently, last week, I have attended the Oracle interview. They asking the same the IP address, like scan IP or scan name, how it is getting, know this all this node connection and other details. They're asking deeply, sir.
Yeah, again, I just mentioned one-liner definition for the scan. Like I mentioned, why three IPs for scan? That's a client-side high availability. And then load balancing, we're able to achieve by scan. So if you go in deep, scan itself is a separate chapter in our RAC course. What is scan? What is scan? Okay, then we talked about why scan has multiple IPs and then how scan is aware of load on my cluster nodes. Again, that is all like you are going further internal to your rack architecture. So let's say I just mentioned here my scan, if client connections comes, the client connections comes, your scan will route the connection to node 1. If the second connection comes, my scan will route that connection. Okay, node 1 already has the connection. Let's go to second node. That's where scan is smart enough. Scan is already aware how many cluster nodes in my cluster because scan is my cluster resource. Again, there is too many uh, internal concept you need to understand before we discuss about this one. One is your cluster resource and local resource. And the name itself suggests local resource, meaning locally run on that particular rack node 1 or rack node 2 or rack node 3, which is not aware of other rack node information. Cluster resource meaning the name itself suggests cluster. It's a resource which is running on any of my rack cluster node. It may run on node 1, it may run on node 2, it may run on node 3. And that is aware of all my cluster nodes. And scan is a cluster resource. So that may be other questions. Is a scan local resource or cluster resource? So scan is your cluster resource. So since the scan is a cluster resource, my scan is aware of how many cluster nodes. Is it a 2 node rack cluster? Is it a 4 node rack cluster? Is it a 5 node rack cluster? Is it a 8 node rack cluster? That's a question is answered. My scan is a cluster resource. My scan is aware of how many rack cluster nodes. And we already know my scan is defined with multiple IPs in our DNS with help of network admin. And scan is already aware of how many IPs are configured for the scan. Right? That's answered. And my scan is smart enough. Scan know how many connections are there on node 1, how many connections are there on node 2. How my scan is aware of that, how many connections are there? There's an internal mechanism again. The pmon process of your database instance will communicate with your scan. Let's say your database devdb and the pmon process will communicate with the scan. Devdb2 pmon process will communicate with your scan. So because of that pmon process communication between scan and database instance, so scan is able to identify how many connections are there in DevDB instance 1, DevDB instance 2. Based upon those connections and transactions, The scan will know, analyze, okay, how much percentage load on node 1, how much percentage of load on node 2. Based upon that analysis, it will route the connection to one of the least loaded cluster node. So and then why is multiple IPs we defined in DNS server? Because of client side high availability. That is your answer. So if you're able to identify this one, what we just gave this, that is your answer to that interview questions. Hope that's clear.
Yeah, yes, sir. Like I explained the same way, but still he given some scenarios, sir. Okay, node one, node two, node one have 5 connection, 100 CPU utilization. Node two is like 100 session. There is no CPU utilization. In this case, how the scan will smart understand where we route the connection? Like this, he asked.
Again, that's what I just mentioned, right? If you go back to your fundamentals, what is fundamental? What is the PMON? What PMON process, can somebody tell what PMON process will do? It's a pure your database architecture concept. PMON stands for process monitor. What it will do? We all
It
know, right? PMON process is a process monitor. It will keep a track of all the end user connections. And if end users are connected and what transaction is doing. Is he doing a insert, update, delete, or is he doing a select queries? We know that PMON process job is to monitor all the end user connections, is the end user transactions. And in case of any transactions are failed or network disconnected happened, PMON process is the one which is going to clean up all those resources held by that user. Let's take a scenario here in the same in the interview what they asked, like client one connected, and then connection will go to your node one, and then not doing anything. Client two connected, and then connected to your node one, and not doing anything. And client three connected to scan, via scan connection will go to node two, and then let's say he's doing some heavy transaction. Let's say he's doing some select query, and that select query is a 1 million record is fetching, and then it is doing a lot of heavy IO operations, and your node 2 is heavily used here. And client 4 comes, node 1 has 2 connections, and node 2 has 1 connection. My scan, where it going to route this fourth connection? Is it going to route it to node 1, or is it going to route it to node 2? If my scan is routing based upon number of connections, meaning, okay, node 1 has 1 and 2 connection, node 2 has only 1 connection. Okay, let's route this fourth connection to node 2. Then there is no advantage of scan. Scan is blindly routing the connection based upon number of connections. No, that's not how it's going to work. My scan is aware, okay, even though node 1 has 2 connections, client 1 and client 2, but they're all idle, they're not doing any transaction. And my scan is aware, client 3 is connected to node 2, but they're doing heavy transaction. And whatever the client 4 connection comes, will always go to node 1 only. If the client 5 connection comes, it'll always go to node 1 only. How? As I just mentioned, PMON process of my database will communicate to your scan and tell boss, I have 2 connections, client 1 and 2, but they're not doing any transaction. The PMON process of your DB instance 2 will tell to scan, boss, I have 1 connection, client 3 connection, is doing heavy transactions. That's the job of PMON, to monitor the user process and analyze what they're doing it. And that information, PMON process of that database instance will pass it to scan. And because of that internal mechanism, scan is smart enough to understand how many users are connected on my cluster node and what transaction they're doing it and how much percentage they use that on that particular node. Based upon that, my scan will always route. If next 10 connections comes, all 10 connections will go to node 1 only because they're not doing any transaction over there. And then you might see now 10 transactions plus 3 transactions, 13 connections are node 1, but only 1 connections are node 2. Even though 13 connections, but they're not doing anything. Even though it's one connection, they're doing a lot of transactions. And if any further connections comes, all will go to node 1 only. So scan will not blindly send it number of connections. Scan will send that connections based upon the how many users are connected on each node and what transaction they're doing it and how much percentage that each node is loaded or utilized. Hope that clear.
Yeah, yes, sir. Now I got clear. Okay, that's what I missed. Okay. And coming to the network part, right? One more question they asked there, sir. So if the node one, node two, right? The node one down. So can we ping from node to for public IP? What will
Again,
get response?
that's where you need to understand here. Where is that one? What is public IP here? Where is that? Where is that? Okay. Here. What
Physical
is
IP.
physical IP or public IP? IP assigned to interface. If you go and then do IF config in your server, you have a Ethernet 1, Ethernet 2, Ethernet 3, and for that your IP is assigned. The moment node 1 goes down, your NIC card is down. You'll not be able to ping, you'll not be able to access. It's all down. What is VIP? VIP does not have any interface and it will be having this tagging. Whatever the interface they have it for that :1, :2, :3 they will tell. And these IP, even though node 1 goes down, these IP will never go down because they are not associated to any interface. If any host goes down, if any IP assigned to interface, that will not be accessible. Same thing goes for your physical IP or public IP. Even it is same thing goes for a private IP because private IP is nothing but it's a physical IP assigned to an interface. The moment you say physical IP, it is assigned to interface. Your public IP is also assigned to interface. Your private IP also assigned to interface. If the node 1 goes down, here let's assume this node 1 is down, you will not be able to ping this physical IP, you will not be able to ping this private IP because both are assigned to a interface, both are physical IPs. One is in a public network, one is in a private network. Whereas your VIP is not a physical IP, which does not have any interface. And you can ping this IP. This ping IP will be floating in any of the cluster node. Automatically going to fail over to node 2 or node 3, node 4. Right? That is your answer.
Oh, okay, sir. I think I missed it. Okay, I given some wrong answer. Okay, sir. So here one more clarification. See, the node only drone, right? But server is up and running. No? So can we ping the public IP, right? That
Again,
is my understanding.
what do you mean by node?
Node
Node
means
down means your server
node.
down.
Yeah, node means like cluster. Maybe you
If
can
you say
assume that.
cluster down,
Yeah.
then only the services are down. Right now, you can think of that's what I mentioned in the beginning. We call it as a node or we call it as a server. In Linux or in RAC concept, node meaning server, node down meaning your server down, or node services are down, meaning your cluster services are down. Cluster services are down meaning only your ASM and database are down. Your physical
Mm-hmm.
IP, your public IP, private IP, all are accessible. You can ping,
Oh.
right? You need to be very cross question. Whenever they ask these questions, you need to
Mm.
ask, you get a clarity. Node down meaning what? Is it a server down or only that services, cluster services are down?
Mm-hmm.
And based on
Okay.
that, you have to answer the question.
Yeah, got it, sir, now. Thank
All right. So those are the wonderful questions. Again, those are the wonderful questions and basics. And if you go rack internal, there will be much more. But these are your fundamental understanding of rack networking and rack architecture. All right. Two more things we can talk: rack installation and then rack administration. And then let's talk about um okay, rack architecture. Okay, rack installation. And let's go before that rack architecture. Right. We'll talk about little more. Whatever we talked about is just a basics of networking in rack. Now let's explore more on installation. Give me 1 minute. We'll talk about these three concepts in a minute. All right, sorry for that. Okay, let's explore on the architecture and installation and the administration part shortly. Okay, earlier, prior to 10G, let's think of older version. Prior to 10G, there are three softwares. In 9 and all, we used to install three softwares. The clusterware software, ASM software, and database software. Meaning same concept, what we did here. Node 1, Node 2. Again, that's your cluster. So we used to install this first cluster software. Download and install this cluster software. Let's say use your own cluster. Use your own cluster. The moment you install this cluster software, this node 1 and node 2 will act as a cluster and start will communicating, which will help node 1, node 2 communication and make two node cluster. And after that, we used to install this ASM software. Install ASM software. You have to download that ASM software and install it. Let's say use your own ASM. And then we used to get ASM instance and ASM storage with help of this ASM software. And post that install DB software. We have to download that database software and install it. Use your own DB software. Once the DB software installed, we can create any database. Let's say I create DevDB and we'll be having DevDB instance 1 and DevDB instance 2. Here once we ASM instance is created, it will be plus ASM1 and plus ASM2. So that is our typical installation earlier prior to 10G. And 10G and post, Oracle, what they did, they came up with this grid concept, the grid software. What they did, they combined this clusterware software and ASM software, where we used to install two software. They combined it and made it as a called it as a grid software. Grid software is nothing but clusterware software and ASM software. And now what we're doing, we're installing only two software. Node 1 and Node 2 will install that grid software. After downloading that grid software, use your own grid, use your own grid. The moment we install this grid software, which will help us node 1 and node 2 communication and make two node cluster, and which will help us is whatever that ASM storage and ASM instance. Right after that grid software installed, that will gonna bring your ASM instance and it will set up your ASM storage and it will set up your clusterware communication or clusterware resources. Post that your database creation remains same. Install the database software and create your database. That's a simple difference prior to 10G and post 10G. We're installing only two software nowadays. Earlier it was three softwares. And then many people will call it as different names. Let's say grid software, or you call it as a clusterware software, or you call it as ASM software. All are one and same. Right? That's what I mentioned here. Grid software is a combination of your cluster software and ASM software, where earlier we used to install it two different software. So if somebody talks about these are like one and same. Grid, cluster, and ASM software. And if somebody say grid home, GI home, or ASM home, or clusterware home, or sometime they call it as only short grid home. So these all are referring to one and same, where you install that grid software. They call it as a GI, grid infrastructure home, or the GI home, or the grid home, or the ASM home, or clusterware home. All are referring to one and same, the location where you install your grid software. And many people will call it as a Oracle software, database software, or DB software. Both are one and same. The database software, what you downloaded. And with help of the database software, where you are going to install them, where you're going to unzip them. Those are called your Oracle home, DB home, and database home. Whatever name you call it as, that's all referring to your database home, where you unzip your database software. Right? Different naming convention, but all are referring to one and same here. Right. Now, How you will install it? Grid infrastructure, ASM, or cluster level installation. How we'll do that? We are going to download this 19C, again grid software or ASM software or cluster software. Call it as whatever you want on node 1. And then unzip that 19C GI software into which directory you want to unzip that. That's your GI home. I'm going to unzip that user on app 19C grid. In this location, I'm going to unzip that 19C GI software. Once I unzip that, inside that there will be a grid setup. I'm going to run this one. Give me 1 second. All right, sorry for that. So we're going to run that grid setup from that node 1 where I unzip that grid software. And then it'll ask you to enter physical IP, VIPs, and scan details. I'll enter it. And then it's going to copy that ASM or GI or clusterware software from node 1, whatever you unzipped here. It's going to copy it to your second node and start your ASM1 and ASM2 and set up your cluster. On node 1, node 2, you have this grids home ready, and then your ASM is ready. All the cluster services are ready, and your ASM storage is ready. And post that, once you've done that one, then we'll go with the Oracle Oracle home or database home or RAC home. We call it as many names. All are referring to one and same. Same thing, download your 19C Oracle home or database software on node 1. Unzip that database software into that location where you want to unzip the database software. User 1 app Oracle product 19C DB1. From there you can run this run installer. It will show all the rack node, whatever the rack node we configured here, node 1 and 2 and 3 and 4. It will show all of them. And then if you select all the nodes, and then you're going to copy that Oracle software to all other node, whatever node you selected. And then post that, you have a grid home on node 1 and node 2. Your ASM1 and ASM2 will be running, and you got your Oracle home on node 1 and node 2. When that Oracle home is ready, now we'll go with the database creation. Database creation, connect to your node 1 or connect to your node 2 or whichever cluster node. Go over there, go inside that Oracle home, inside that bin. We have something called DBCA, Database Configuration Assistance. Run over there, and then it'll ask you to enter all the database details. Your database name, SID, SGA, PGA, data file location, FRA, arclog location. Enter all those details, and you're going to create that database. And post that, you have your node 1, node 2, grid home, your ASM1, ASM2, your Oracle home on node 1 and node 2, and your database instance 1 and database instance 2, whatever you entered here. It's a RAC database running across multiple nodes. Right, that's a quick high level overview how you can how you can set up your rack, the rack installation of two node, how it was earlier prior to 10G and how it is now post 10G. Hope that's clear. Any questions here on the installation part? All right. If no questions, then go with the next one. We'll go with this little bit of administration and then we'll go to the fundamental architecture. What we talked in yesterday's session, uh, if it's a standalone and how you're going to manage. Let's say if it's a standalone database and how you're going to manage that one. So the moment you say manage the database, what database consists of. If you go back fundamental architecture, let's say you standalone database, we have DB database in a standalone server, meaning I have this one single server where I have this instance and then I have this database here. So this is the DB instance and then this is your DB. Again, DB is DB. It may be same name. So when it comes to standalone, whether it's run under OS file system, whether it's run under ASM file system, if it's a ASM database, then you will be having same instance, and then this instance will be running under this ASM storage here. Here it is your DB instance, and then here it is your DB. And again, DB is again same DB. Only difference here, your DB database running under this OS storage here, and here DB database which is running under ASM storage. Only storage is different. So here this is OS storage managed by your OS operating system itself. Here it is a ASM storage, and this ASM storage is managed by your ASM instance. Only that's the difference. If it's a standalone, what we do, we basically manage our database instance and we manage our database. That's the data files. And the moment I say database instance, which is a combination of your memory and background process. The moment I say DB database, that's your data file, or you can say storage files. It may be under OS storage or it may be under ASM storage. So that is what we manage in case of standalone. To manage the database, we use either srvctl or we use SQL plus. SQL plus command line to connect your database and do all the administrative activities. Create user, grant permissions, check the privileges, or create a roles, profiles, and table spaces, add a data file, create a table space, whatever activity, whatever our day-to-day activities we do by connecting to the database instance. And if it's a ASM one, if database running under ASM, we use this srvctl and check stop, start, you srvctl config database, check the configuration of my database. Where is the SP file? Where is the password file? And what is the DB name, DB nickname? What's the instance name? What are the resources? We use this srvctl config, check the database instance, stop the database, start the database. Even you can do using SQL plus to stop, start database. But if it's a ASM one, you can either use SQL plus or you can use srvctl to stop and start database. But that's a simple high level overview for standalone database, how you can manage and administrate. Same way, if you correlate your RAC database, is there any difference between standalone and RAC? Same, RAC is also a database, standalone also a database. Let's say same database here, but it's a RAC. In case of standalone, only one node, your instance will be running and your database will be sitting. But in case of RAC, you will be having your instance 1 and will be having your instance 2 and your underlying database remains same. So what we used to maintain your instance, you're going to maintain two instances here, but underlying database remains same. So meaning same concept here, manage my database instance. So the moment I say database DB in standalone, here it's a DB instance 1 and DB instance 2 because there are two instances are running on two nodes. But underlying database DB data file remains same, one set data file, not two set here, which will be under your ASM storage. At the moment I say my database instance will be DB instance 1 and DevDB instance 2. So we'll be having same memory and background process. How this DevDB instance on standalone has a memory, HGAPG background process. Here, this instance, DevDB instance 1, DevDB instance 2, two instances. They will be having a two separate set of memory and background process. DevDB instance 1 has its own memory and background process. DevDB instance 2 has its own memory and background process, HGAPG and all the background processes. Same, no changes at all. And whatever the utility we used here to manage my database. So underlying this database remains same. Your DB will be under your ASM storage here, mandatorily. And you can connect using SQL Plus to maintain your database. SQL Plus. Here, in case of DB, we used to connect to this only one instance to maintain, manage, or administrate, create data file or add data file, create table space, user creation by connecting to this DB instance one. But whereas in case of RAC, either you can connect to your instance one or connect to your instance two, and you can do all the admin activities. Create user, grant permissions, create role, create profile, create table space, add data files. Whatever activity you wish to do it here in this DB instance, you can do it from any one of the node. Underlying your database is remain same. So you don't need to do it on all the nodes. You just connect to one of the instance, DB1 or DB2, and do all your admin activity what you used to do in this standalone. Right, and then SRCTL remains same. Whatever we used to do this stop start, you can do the same operations here. Stop database, status, start database. If you do, you're going to internally shut down your instance one, instance two. And there are few extra command instance specific. I want to bring down only this instance one. Let instance two up and running and let's access the database. For that, you need to go with the instance specific. So you're going to do srvctl status. Now it's not a database. I want to go with instance specific. Instance. And what instance? I want to go with my DevDB instance one. And which database that instance belongs to? DevDB. I want to stop that instance. I want to start that instance. Instance one. Same thing, I will go with the instance two specific. srctl status instance, DevDB instance two. Stop the DevDB instance two. Start the DevDB instance two. You can go with the instance specific or you can go with the entire database. The moment entire database meaning both instances will be down automatically. Right. So in when it comes to your administration, whatever admin activity you used to do it for standalone, no changes at all. We're going to do the same admin activity for your RAC database. Only thing is you can connect to either instance one or instance two. You can perform your activity. But what extra here? Along with this database administration, one extra activity is added up here. My cluster management. This node 1 and node 2 are communicating each other or not. Node 1, node 2. They should communicate each other. All my cluster resource running fine or not. That's the extra major activity what we perform in case of RAC. Using something called CRSCTL. Whatever this SRSCTL is server control utility to manage, maintain, administrate your database, database services, listener, and other cluster resources. Other cluster services. And when it comes to cluster resource or cluster management, we use tool called CRSCTL. CRSCTL is a cluster control utility. We manage all the clusters using this tool. There will be a lot of cluster resource. There will be a lot of cluster resource. There will be a lot of cluster utilities. A lot of cluster resource, cluster daemon, and a lot of startup sequence. We're going to manage, maintain everything using this serial. A few examples are we're going to check my CRS, cluster ready service. We're going to check my HAS, high availability service. And we can stop and start CRS. We can stop and start HAS. And we can check the status. Stop CRS. Again, I'll not go with the force at this point. I can stop CRS. I can stop and start HAS. And what is the impact? You need to understand once we go with a regular class. So if you go here, one single slide, what all the services will come into picture? Okay, these all the services will come into picture. OHSD, Oracle High Availability Service Daemon, and your CSSD agent, Cluster Synchronization Service Daemon agent, Ora Root agent, Ora agent, and CSSD monitor, Cluster Synchronization Service Daemon monitor, and CSSD OS process, and CSSD monitor OS process, CRSD, Cluster Ready Service, CTSSD, Cluster Time Synchronization Service Daemon, Disk Monitor, ACFS driver, your ASM, GIPCD, Grid Inter-Process Communication Daemon, GPNPD, Grid Plug and Play Daemon, EVMD, Event Monitor, MDNST, the broadcast messaging, again Vara Root Agent, Vara Agent, and your GNS, ACFS, SCAN, GNS, Node VIP Network, ASM, ONS, EONS, GST, Listener, Scan, Services, DBs, and disk groups. So many things. All are your cluster resource and local resource. We are going to manage them. Those are my extra activity when it comes to cluster. We have so many utilities. We have OCR config, OCR tech, other uh, cluster tools. Let's say a few of the cluster tools. If I remember, your Cluffy and your OCR config, OCR check, and then OCR dump, your OLS nodes, right? And then your CRS ETL, SRV ETL, and then there's so many other tools and other resources. These are your few other cluster tools which will be very useful or helpful for my cluster level management or administration. Based upon the need, we use all these tools, right? And then again, a lot more to cover with respect to tools. Those are must needed or need to understand when you start supporting these cluster level activities. Right. And then again, I'll take a pause here for a minute. It's just a brief comparison I just gave you. What extra comes for when it comes to RAC administration in comparison with the standalone database versus RAC database administration? It's absolutely remains same, no changes at all. But what extra comes here? Your cluster level management is one where we never do it in case of standalone. But in case of rack or cluster, that's the extra activity or major activity what we do. Right. Any questions here so far on the installation part or the administration part or the networking what we covered so far?
Yeah, Mallikarjun, now we have 23A and 26A also released, right? So
Right.
is there any new features or updates added to that track in terms of AI?
Your entire database itself got changed. Your database in 19C till 19C or till 21C, it's all a normal traditional RDBMS database. And with this 23 AI or 26 AI, your database is a vector database. Vector database meaning it's a no more like normal RDBMS, relational database. You can store your data inside your database in a JSON format. You store your database in a relational table format, and you can get whatever data with whichever format you want it. So your search engine mechanism, everything is changed. A lot of changes happened, your entire architecture wise and database wise. And again, the fundamental concept remains same, whatever this management maintenance, but inside database, you can store your database in the raw JSON format, and you can pull the data in the same JSON format. That's called your vector database. And your database is not no more OLTP or OLAP. It's a combination now mix. Your database is one, you can run any workload, whether it's a OLTP or OLAP, and your database is able to handle it in one single database. That's one thing. And on top of that, there are so many new features. All right. Quick little bit. We talked about this in yesterday's session. I can just quickly brief it and then we can wrap it up. We talked about this one in yesterday's class, type of database, standalone, that's a DBA course where we understand standalone without ASM. The database is running under OS file system. That's assuming it's a DevDB. Standalone with ASM, your database is running under ASM file system. Let's understand that's the test database, which is highly recommended by Oracle. We covered that in yesterday's session. Why Oracle recommend you to run your database on your ASM file system. And then in RAC database, in this course, we'll be covering this RAC database, DevDB1 and DevDB2, that's a RAC database. And RAC one node database, DevDB_1 and DevDB_2, that's only one instance will be running at any given time. We talked about this in yesterday's session, but why I wanted to cover this one, and also we covered this one, why RAC, what are the advantages of RAC, and then okay, before that, why Oracle recommend to run database on ASM. We talked about this one. If I go back to my yesterday's notepad here, where is that? Okay, here, why Oracle recommend you to run on ASM storage? So ASM has this lot of advantages what we talked. Right, so why ASM, why Oracle ask you to run your database on ASM? Because of these many advantages: mirroring, striping, redundancy, external normal, high Oracle restart, high IO performance read and write, ACFS, and many more. And then also we understood about why RAC, what are the advantages of RAC in our yesterday session. Sorry. High availability, failover, load balancing are the primary features of RAC. Right, so that is your standalone versus RAC. These are the major differentiator. Why RAC? These are the major advantages. What are the advantages of RAC? These are the major advantages. Right, so if a simple definition, we talked about this one, HA, high availability. If we think of in more details, high availability, multiple RAC cluster nodes will help end user to connect. In case of any node down or any server goes down, other node will be available to take that incoming connections. And then scan will come into picture here, and then scan will provide you a client side availability because of scan has a multiple IPs. If one IP is busy, other IP will take that incoming client connections and serve that incoming connections. Scan will provide you this client side connection high availability, and server side connection load balancing. Scan will route that connection to your available cluster nodes with a load balanced. Right, so that is main advantage. What exactly mean of high availability? Multiple nodes will be available. In case of one node goes down or one server goes down, you have other server. My scan will route that connection to other available nodes. Failover, what we talked about failover, and there may be multiple questions around this one. Who is responsible for failover? Sorry, before failover, let's understand load balancing. Who is responsible for load balancing? We already learned that. We already explained in details. Scan is responsible for maintaining that load. And again, we understand that what is scan. And then we understand that default scan is made up of three IPs, or that's the three VIPs. How scan is able to perform load balancing? Because scan will communicate with the PMON process, understand the load. Scan is able to identify the load of that particular server, how many users are connected, what transaction they are doing it. How many IPs scan has it? I just mentioned default three, but is it a mandatory? No. You can have even one, two, three, four. But having three IP, I already told, that's a client side connection high availability. One IP is busy, other IP will take over that connection and then serve that client connection. Is a scan a VIP, physical IP or IP? We already talked. Scan is a VIP, similar to that node VIP. So people will call it as a scan IP or scan VIP, but remember scan is always a VIP. But ease of understanding, people will call it as just a scan IP. It is all about your load balancing. Only person coming to picture is your scan. The load balancing meaning scan. Scan is responsible for handling this entire load balancing. The high availability meaning again scan. Scan is aware of how many nodes are available in my cluster, which node are down, which node are up, and it will route that connection to whatever the available node. And again, last advantage is failover. We already talked about that failover. What all the failover supported? DML, DDL, TCL, any select query? What all load balancing supported? Let's say if I go back here, scalability, manageability, not this one. Okay, let's go here. Okay, here. Let's say client one connected. Let's say we have a table called employee table here. This employee table has 2 million record. Select star from employee. The client one has fired that query, select star from employee. Out of this 2 million, let's say 1 million record came here and this server went down. Automatically, this client connected to your second node. 1 million record already fetched. Will it start from the scratch, from the zero, or it will start from that 1 million record? Or let's say client connected over here. He is doing same employee table, update. This is select. He is doing update. And out of the 2 million record, 1 million record he updated. Another 1 million record it has to update. Let's say this instance failed over. And then connection will go over here. And then once the connection fail over, will it continue from that 1 million record or it's gonna cancel that 1 million record, start it from the zero update statement. So that's the fundamental questions. Is my failover is only for select query, a DML query, DDL query, TCL query? So default answer is only select queries supported for failover, but there is a mechanism we can extend it to your DML query as well. That's again we discuss in our regular class. Only for answer, only select query failover is supported. We can think of, we have two options, select query failover or session failover. Meaning if I remove all this, right now this failure happened here, it is a select query. So if this failure happened, we have an option. When the failure happens, discard all the data, whatever it is full, start it from the zero, fresh. Or when the failure happened, continue from where it has left out. Two options you can configure while doing this failover. We have to configure that failover. We call it the TFA, transparent application failover. Once you configure, then only this failure occurs. If you don't configure, failure will not occur. The end user connections will be broken. So while configuring this TFA, you can do configure what type of failure you want it. You want only this session failure. If 1 million record is fetched already, discard that and establish a brand new session started from the zero. Or select query failure, meaning wherever situation it has left out, fail over the client connection and continue from where he left out. That is the option you need to select while creation of this TFA. But then how we are able to provide this failure feature? With the help of TFA and with the help of VIP. VIP is the one backend which will be responsible for this failure. If without VIP, you will not be able to do failure. Right? Answer is VIP will help in achieving this failure. Without VIP, there is no failure concept. There is no TFA at all. Again, other questions. Why we need VIP? That is because to handle this failure scenario. Without VIP, failure is not possible at all. Right? What all the transactions are supported failure? What we just discussed here. The answer is only the select query failure is supported. There's other mechanism. We can have some DML query also to failure, but simple answer to any interview questions, only select query is supported for the failure. The TFA, transparent application failure, we support select queries. Right, so that is in continuation to yesterday's advantage why RAC, and then couple of questions or multiple questions around that failover, load balancing, and high availability. And majority of them are handled by my scan and the VIPs. And again, if you further go down, the other advantages or other important questions around your private IP. In the private IP itself, you can see why private IP should be in a different network. Why can't it be a same network of my physical IP? And private IP is used for cluster communication, network heartbeat. What is this network heartbeat? What is this disk heartbeat? What is this cache fusion? And then we have something called when you talk about this private network, we have something called split brain syndrome. That's also one of entry questions. What is split brain syndrome? How we can handle it? And again, we talked about here node to node communication. We talked about node to voting disk communication. And what are these voting disk? And then again, if you go further in depth internal to rack cluster, we have OLR, OCR, voting disk, and there's so many concept we need to understand that we will take it once we start our regular class. But with this, again, I'm going to wrap it up for today. If you have any questions around this, whatever the topic we covered, we'll spend few more minutes. Otherwise, we can wrap it up for today. Hope that's all clear. I tried to make it simple and simple layman term. I wanted to explain how this rack architecture works. That's a high level architecture. But once you start our regular class, you can see more details and then further more to this what we covered here high level. All right. Any more questions, guys, before we stop it or wrap it up for today?
Yeah. Thank you, Malik. I think it's very clear. I think it's for wonderful.
All right, guys. All right. With that, if no queries, let's take a break. And then please do reach out to me if you have any further questions or queries. Ping me on my WhatsApp number or cell number. I'll try to clarify. And then again, if who are interested to enroll, again, reach out to me and my cell or WhatsApp. We'll take it further for registration. All right. Take a break, guys. Thank you all.
Malik, out of this question, like I think is like currently everybody is moving to Postgres, right? So what is the future of Oracle going forward? Because
Everybody moving to
Postgres, most of them are moving to
Postgres again. You think of what exactly Postgres, what exactly MongoDB, what exactly MySQL, what exactly all these database, right? So if you consider your MySQL, your PostgreSQL, these are not the enterprise databases. Not the enterprise database, meaning any new companies who are startup, they will look for free edition and they will look for some for small startup, small business. They look for some NoSQL database where they can support some little transactions. And then whatever they migrate for NoSQL and MySQL or Postgres, that's all their business will run fine. But when their business grows up, when they become an enterprise customer, and if the database grows up to terabytes, and only Oracle is the one which will support, and none other database can support. Let's say I worked for MS SQL database as well, and worked for uh, Oracle database, and I worked for DB2 SAP HANA. And whatever the workload, whatever the database size I seen it in Oracle, it is in terms of terabyte. I worked on the database starting with a 50 terabyte and up to 800 terabyte. And if you compare with any other database in the world, in my career, I never seen MS SQL database more than 10 or 11 or 14 terabyte. I never seen any SAP HANA database more than 11 or 12 terabyte. I never seen any Postgres database which is more than 2, 3 terabyte. Comparing to this enterprise database or enterprise customer, and none of the other database can handle this kind of a 100 terabyte, 200 terabyte workload. You cannot run your 100 terabyte database in Postgres. You cannot run your 100 terabyte in SAP HANA or DB2 or MS SQL. So looking at this Fortune 500 companies who are enterprise, all their workload has to run under Oracle only. Considering their database size, no other database can able to handle that much of size and load. Right? There's no never ending for Oracle database, and only this Oracle can support this huge data volumes. And having said that, this Postgres SQL is not the enterprise support. There will be a lot of security concern, vulnerabilities, and when it comes to real production issues, and there's no proper support, like your Oracle, when it comes to security enhancement, and nobody can hack or nobody can break it. No vulnerabilities. No hackers can break the Oracle database. Right? Considering all this security risk, the huge data volume and load, all the enterprise customer, this Fortune 500 customer, they should run their database in Oracle only, nothing else, or no other Oracle, no other database can support this much of a workload or the size. Right? Yeah, that is my learnings. So many years with many customers.
Hmm.
No other database can handle this load. All right.
Yeah, I agree with that. Yeah.
All right, guys. Yeah, with that, if no more questions, let's take a break. We'll continue with our regular classes. Thank you all.